Hi everyone, this is Luis, project lead at Aragon, and today we're gonna do a virtual reality walkthrough through Aragon OS and the core of what powers Aragon, thanks to Primitive. So for those that don't know about Aragon, Aragon is a platform to create decentralized organizations, basically organizations that are in the blockchain and live in the blockchain, and they are powered by software versus traditional organizations that are powered by bureaucracy or nation states or banks or this kind of central entities. And we use Ethereum, which is a blockchain that allows people to create smart contracts, and these smart contracts are self-enforceable pieces of code that run into this blockchain. So for the matter of creating decentralized organizations, we have decided to create the operating system for creating these kind of entities. And so it's basically a very thin layer which provides you upgradability and also authorization for smart contracts. So I guess I will just jump in and explain like all the different components. So first of all, we have contracts, as we can see here, and we have different subfolders for different pieces of Aragon OS. One of the most important pieces is the kernel. It's a very thin layer which basically keeps track of an ACL, and the ACL is an access control list. So basically it is the list which actually knows which apps can call other apps, because in Aragon OS there is a concept of apps, and these apps are basically pieces of code that do one thing and do it very well, following the Unix philosophy. These apps are allowed to call functions on other apps, or in general, any Ethereum entity, any blockchain entity is able to call functions on these other different apps. So for example, one function can be to withdraw money from like a vault, for example, which contains assets and contains like Ether and other cryptocurrencies. So this is the kernel, and the kernel, as I said, just keeps track of the access control list, and also it allows itself to be upgraded. This is the actual implementation, and we are going to see here just the interface. You can implement your own kernel, and if it follows this interface, it will be compatible with Aragon OS by default. And then we also have a kernel proxy. So basically we use this pattern in Solidity called proxies. And so what the proxies do is they know where's their actual code, and what they do is when they are called, they just delegate the call to their actual code. So basically you can have different implementations, different code bases, different versions of the same package or the same code. And using this proxy, you can route the call to the correct version that you want to route it. So it is very, very interesting for upgradability and allows smart contracts to be upgraded. And then finally, we have the kernel storage. And that's basically the kernel. It's a very thin layer. So now I'm going to go through the ACL, the access control list, which is a very crucial part of Aragon OS. Cool. So here we have the implementation of the ACL, and I'm going to try to focus on just one function which is down here, set permission. Basically, with this function, we can understand how the permission system works. So you can set a permission to address an entity, can be an Ethereum address, and you can set a permission to this for this address to be able to call an app, and this entity will be able to call this actual role in this app. And a role can mean different things, but usually it's just like a set of functions that this entity will be able to call on this app. So these functions can be, like as I said before, the withdraw function on a vault which stores assets, or for example, if we are talking about a voting app that allows people to vote, the role can be just voting or open a new voting. And if it's allowed or not, which is basically if we set it true or false, and we basically add the permission or remove it. Then all the permissions have a permission manager, which is the super user that is allowed to change the permission afterwards. But basically those are the two functions in which we can see how everything works here. And this is all the logic for making it happen, and as you see, all the different commands for granting permissions, revoking permissions, setting the permission manager. We have the interface, which is like a super, super simple lines which actually specify the interface for the ACL. So that's the ACL. For making all of this happen, for having different apps that are upgradable inside the smart contracts, we have created a package manager, which is called APM. So basically, if you're familiar with Linux, you will know that in order to upgrade the operating system, you have different repos, and these repos contain packages. We have our own implementation of what a repo is. And a repo is just a smart contract which can track new versions of a software package. So this software package can be both smart contracts and also any arbitrary data, for example, like a web application. So how we use this in Aragon is that when you upgrade an app, you upgrade the smart contracts and you also upgrade the UI, which is a web application basically. And also the cool thing about these is that these upgrades can be powered by any sort of governance mechanism. So you can even have to go through voting to actually push a new version. So you make sure that the contracts and everything that is pushed is actually something the community wants. So you can get the latest version from an address, or you can get a specific version with semantic versioning. The cool thing is that this all works with the Ethereum name system, and the Ethereum name system basically allows to have very cool names, like for example, finance.app.aragonid.eth, which could actually drive you to the finance app in Aragon. So now talking about the Ethereum name system, this is some contracts that we have for integrating ENS into Aragon OS. So these are some constants, and then we have a subdomain register. And what this enables is for an organization to own its own ENS domain and then being able to actually create subdomains on that domain. So you can have this organization which owns aragonproject.eth, and then you can have different roles, as we see here, for people to create subdomains, which will be luis.aragonproject.eth or something like that. So with these roles that we see here, will be available for other apps to use and to consume them. So we could actually have a function here which is called create name that only allows create name role recipients to actually call this function. And so this is super handy because then you can have different entities that can create domains and can own them and can point them to different addresses, like Ethereum addresses. So this is our ENS integration. What do we have here? Well, we have multiple apps that we see by default, but here we just have the implementation of what an app looks like. As you see here, all the apps are moved to a different repo for simplicity's sake. But here we have the implementation of what is an Aragon app really. So Aragon apps just have to specify that they are Aragon apps, and this is where Aragon app, this class, so to say, is defined. So an Aragon app has some storage, and then also has some ACL power, and has something called the EVM script runner, which is basically a way for apps to forward actions to other apps. So for example, let's say you want to withdraw funds from a DAO, from a decentralized organization, but then you don't have permission to do that. But there is a voting app which actually has permission to do that. So what you can do is you can say to the voting app, hey, I want to open a voting, and if voting passes, then I want to withdraw funds. I want funds to be sent to this other address. And so this EVM script runner allows us to forward actions from the user to a voting app, for example, for the voting app to actually execute it. So as you see here, it has a can perform method, which is basically checking with the access control list and asking it can this sender call this role on this app here? And if the answer is yes, then you can call it. If not, then you're not allowed to do so. So you have to look for other way. And then it defines multiple classes. For example, the app storage, that's for obviously for storage, contains the app ID, contains the kernel. So basically, the app knows to which kernel it belongs. It's a sort of exokernel architecture where the kernel is not very monolithic. It's just something that sits between the apps and the ACL. So the apps have to keep track of their kernel. And then also it has a proxy sort of mechanism that I was talking about before, in which you have an app proxy, which can be a sort of a static contract, which can be the finance app or whatever. And when people call it, they are not calling the contract in which the code actually is. They are calling a proxy, which then asks the kernel, hey, I am the final step. What is my actual, where is my code? Where is my actual code? And then the kernel checks and, basically returns that to the proxy, and the proxy delegates the call to that, to where the code actually is. So that enables for very rich upgradability. And that's all here in the different app proxy classes. And well, we have some factories. So factories are basically a way to deploy sort of factory contracts, which then you can call to deploy instances of some smart contracts. And it's a very cheap way to deploy contracts. So you don't have to deploy them like, using the sort of traditional method, but rather you can save a lot of Ethereum gas by just deploying a factory and then just calling that factory to sort of clone multiple instances. Then we use Zeppelin for a couple of things. It's a very common library in the Ethereum ecosystem. We have some stuff for like doing migrations, which is basically deploying stuff to the blockchain. And also we have EVM script, which was the thing that I was talking about before, that helps us forward actions to different apps when they require that. And I think this was a pretty good overview of what Aragon OS is and what it does. And I love to be able to visualize all of this here. I think it's very important that we take care of solidity and reviewing every single line of code that we publish, because they may control, millions of dollars in value. So it is very important that we use this kind of tools to actually check that everything is safe and will actually work as intended. I'm very looking forward for us to use Primitive more, and I think it's an awesome tool to check that we are doing things that we should and do an overview of the architecture and even onboard new developers. So I think that's it.